right, we are on page 168 in the Big Math book, continuing on the chapter 4 mid-chapter check. We have some word problems here. They're a little stretched out. That was just to give myself some more space. So let's take a look at 15. Anna has 296 coins in her coin collection. She put the same number, that means we're dividing, equally same number of coins in each of 7 jars, about, and that word about means we're estimating how many coins are in each jar. Well, since we're using about and we're estimating, I want to make this problem easy for myself, so I'm going to look here for compatible numbers to 7. So I'm going to look at the beginning of 296 and just look at that 29 in front, or 29 tens. Man, if that was 28, 7 goes into 28, nice and easy. So I'm going to set that problem up to something that's going to be easy for me. I'm going to estimate that 29 tens to be about 28 tens and add a 0 placeholder for the 6 and divide that by 7. Now my problem is going to be much easier. Number 16, which 2 estimates is the quotient 345 divided by 8 between? Question mark. So here, again, I want compatible numbers, but I want a high estimation and a low estimation. So if I look at 34, what's the closest number to 34 that 8 will go into, but that is bigger than 34? This is for my high estimate. So if I count by my 8s, 8, 16, 24, 32, 40 is the next one. So my high estimate is going to be 40 with a 0 for the 5 divided by 8. And then for my low estimate, what's a number close to 34, but that is smaller than 34 that 8 will go into evenly? Well, again, I count by my 8s. I don't want to go past 34 this time. 8, 16, 24, 32. So I make that 34 a 32, add my 0 placeholder. So again, I'm using compatible numbers again, but I'm using a high estimate and a low estimate to get my numbers between numbers. So we would say the answer is between what we get for our high estimate. So it's going to be between this number and this number. Okay. Now, I noticed before on the last lesson where we did this, some students would get one of these numbers, but then, so they'd get 400, and then for their low estimate, they would just go one lower than this and go 39. But 8 doesn't go into 39 evenly. That's why you want to use numbers that 8 will go into evenly, nice and easily. So your multiples of 8. That's why we went over multiples at the beginning of the division lessons in chapter 4. Okay, number 17. A peanut vendor had 640 bags of peanuts. She sold the same number, equal amounts, usually means division, of bags of peanuts at each of 8 baseball games. And then our question, the most important part, how many bags of peanuts did she sell at each game? So again, we're dividing. Again, I can use compatible numbers. I'm going to do 640 divided by 8, but really I can look at that as 64 divided by 8. Okay, number 18. There are 4 students on a team for a relay race. How many teams can be made of 27 students? So I can use repeated subtraction for this one. If I wanted to, I can minus 4, and each time I take 4 students away, that would count as one team. Or I could just divide 4 into 27. Now this is really what we're doing is interpreting the remainder. So figuring out, because 4 won't go into 27 evenly. So in this particular problem, the question says how many teams can be made. We don't need the remainder in this case because it just wants to know how many full teams can be made, not how many teams they need to satisfy all 27 students. They just want to know, hey, how many full teams of 4 will we have there are going to be some students left out in this particular problem because of the way they asked the question, which is really what we care about. How did they ask the question? What do they want to know? Number 19, 8 teams of high school students helped clean up trash in the community. Afterwards, they shared 23 pizzas equally. If they shared them equally, same amount. All those words mean division. And then our question, how many pizzas did each team get? So, again, we're dividing the 23 by 8. And again, we're interpreting the remainder on this one. Can you have part of a pizza? Yeah, of course. You can say, oh my gosh, he ate half the pizza. So in this particular problem, there is going to be a remainder, but we want to interpret that remainder as a fraction on this problem. So we're going to get our quotient, which will be a whole number. A whole number is just any number, 1, 2, 3, 4, 5, 6, 7, 8. But then our remainder, remember wherever it says remainder, and I'm just using an example here. Let's just, for example, say it was a remainder 3. Well, to interpret our remainder as a fraction, the remainder becomes our numerator on the fraction, the top number, and the denominator is whatever that divisor was to begin with, what we divided by. And we divided the 28 pizzas by 8 teams. So our denominator, would be 8 on that problem. So now again, this is not the answer. I'm just using these as examples. You can rewind the video if you want to get rid of my x's. But really this question is all about interpreting that remainder. What do we do with the remainder? Well, in this case, since we're dealing with pizzas, we can say, oh yeah, they got 3 3/8 of a pizza, because you can split a pizza up into fractional parts. Okay. On number 18, we didn't interpret our remainder as a fraction because they're not going to have 3/4 of a team. Okay, they're either going to have a full team or no team at all, because you usually don't want to split people up into fractions. Okay, so again, it's basically those last two are all about interpreting the remainder. How should we treat this remainder based on the question that was asked? All right, thanks again for watching. Focus, attitude, initiative, ask for help if you need it, listen carefully.